Hey everyone, and welcome to our C++ tutorial on operators. As you can see, I have Visual Studio pulled up here and our Hello World code ready to go. I'm going to delete the Hello World instruction, and let's start off with a definition. Let's define expression. So for our purposes, we'll define expression as a series of numbers or variables that combine in a valid way to produce, I'm trying to scoot this over, a single value. So this is going to be our definition of an expression here, is a series of numbers or variables that combine in a valid way to produce a single value. So an example of an expression is 2 plus 2. So this is a good example because 2 plus 2 is, a series of numbers that combine in a valid way to produce a single value, and that value is 4. So now in the example of 2 plus 2, we have the value 2, we have our plus sign, and we have another 2. This plus sign is referred to as an operator. So an operator is a symbol in a language that performs an action or operation. Right, so that's easy enough, right? So an operator is a symbol that performs an action. In this case, our symbol is the plus sign, and that plus sign performs the action of addition. It's an arithmetic operator. And these two values are referred to as operands. So that's kind of our rundown of what an expression is and how an expression relates to an operator and how an operator relates to an expression, right? Operators are used to combine the variables or values in an expression. And so let's list a couple operators here. We'll start with arithmetic operators, and these I believe you'll be familiar with. Arithmetic operators are sort of what you use when you're doing normal math, sort of like grade school math. So we have our additive operator. We have our subtraction operator. We have our multiplication operator. We have our division operator. And we have another one that you might not be as familiar with. This is the remainder operator. So the remainder operator is kind of interesting because I'm just going to pull this down here so we have it. The remainder operator is interesting because it, if you remember back to your long division lessons from grade school, you would have some an equation like 10 divided by 3. In the example 10 divided by 3, 3 can go into 10 3 times, and it leaves 1 left over. Well, this remainder operator takes that 1. So if you were to use, it's also called the modulo operator, or mod. And so if you did like 10 mod 3, the result would be 1, right? Because it goes into, one of the operands goes into the other operand any number of times, and if it produces a remainder, then that's what you get with the remainder operator here. Very interesting. Okay, moving on to our next set of operators. We are going to talk about relational and comparison operators. And so let's begin. These also are probably familiar to you. the greater than operator is a good one. There's and that's an example of how to use that would be like, 5 is greater than 2. We have the less than operator. Less than operator. And an example of that would be, I'll move this guy over. An example of the less than operator would be 2 is less than 5. And these both produce true values, right? Produces a true value, and this produces a true value. Okay, so then we have the greater than or equal to operator. Greater than or equal to operator. And that one has so an example of that would be 6 is greater than or equal to 6, and that produces a true value. Also, 6 is greater than 2, also produces a true value. I think you're probably familiar with these. There's also the less than or equal to operator. And so that one is something like 4 is less than or equal to 4, and that produces true. There's also 4 is less than 2. Or sorry, that does not equal true. 2 is less than 4, and that produces true as well. And of course, if you had a number that was larger than 4, like 6, for example, that would produce false, right? Okay, so those are the kind of normal ones, I guess you could say. There's also this one, which is the equal to operator. You might not have seen this one. This one just does the equal to part. So in the example of 6 is greater than or equal to 6, the equal to operator just does the equal to part of that. So we could say something like 6 is equal to 6, and that's true, but these should be, correct this real quick. But in the case of this one, where we have 6 is equal to 2, this is going to be false, because 6 is not equal to 2. So you can see up here we have the greater than or equal to, greater than or equal to. This one is just the equal to part of that. We also have the not equal to operator. And so that kind of just does exactly what it says. So if you say something like 6 is not equal to 6, that's going to be false. But if you say 6 is not equal to anything else besides 6, like 4, that's going to be true. This is the not equal to operator. And this is represented by the exclamation mark or the bang symbol and then the equal to symbol. Cool. So these are all of our relational operators with some examples next to them. Let's move on to our logical operators. And so we'll start with our logical AND operator. And so this one is, I don't know if you might be unfamiliar with this if you haven't taken a logic course or a discrete mathematics course or something like that. But the logical AND only produces a true value when it is given two true values. So an example of this would be true and true. So in this situation, this produces a true value. We can say also you can have a true, false, and that produces a false value, right? So when you have something that is, when you have these two operands, right? And if you can remember back to the beginning of this lesson, we talked about 2 plus 2. The 2 was an operand, the plus sign was an operator, and then the other 2 was another operand. This is the same thing, right? Instead of a 2 plus 2, we have true and true. So if this value, if the left-hand value is true and the right-hand value is true, then your result will be true. However, if either one of those is false or if both of those is false, then the result will be false. So if your left-hand value is true and your right-hand value is false, then the result will be false. In fact, I'll show you a truth table that I can pull up here. I'm just going to dismiss this code window, and I'll pull over our truth table here. So you can see the AND operator. When we have our A value, our left-hand value is true, and true, the result is true. A and B is true. True and false results in false. False, true results in false. And false, false results in false as well. So this is the AND operator, right? This is a truth table for the AND operator. This can be, if you're not familiar with this, this can be a little bit difficult to wrap your head around, but it's very important in coding. So you're going to want to know the AND operator. If you want to take a screenshot of this truth table, or if you look up, logical AND truth table online, you can find one. Okay, so that's our logical AND. We also have one called the logical OR. And so an example of that one, for the logical OR operator, only one of the values needs to be true for it to be equal true totally, or both of the values can be true. So for example, if you have a true or true, then that results in a true result. In another example, if you have true or false, that results in a true value for the logical OR, right? So you can see in the logical AND, it's false, but in the logical OR, it is true. So if we go over to our truth table for OR, you can see A must be true, B is true, then the result of A or B is true. If A is true and B is false, the result of A or B is true. If A is false and B is true, the result of A or B is true. If they're both false, though, the result is false. Right? So with an OR operator, you just need one or the other to be true for the whole expression to be true. For the AND operator, you need one and the other to be true for the whole expression to be true. Okay, our final operator is the bang there, and that is the logical NOT operator. So what the logical NOT operator does is it's unique because it is what's called a unary operator, right? So you can have unary operators, which only affect one value. You can have binary operators, which work on two values. That's like our plus sign. Or you could have even, we might get into this later, but ternary operators, which is an operator that affects three values or works on three values. So the logical NOT is a unary operator, meaning that you only need one value for it to work. And so, for example, if we have a not true, the result of this expression is false. And if we have a not false, the result of that expression is true. It's just a way of sort of negating a Boolean, right? So if you have a true Boolean and you put the exclamation point in front of it, that Boolean will produce a false result when it's evaluated. If you have a false Boolean, you put a not in front of it, that Boolean will produce a true value. So yeah, that's it for our logical operators. These are all the types of operators. So just a quick recap. We have our definition of an expression here, a series of numbers or variables that combine in a valid way to produce a single value. Remember, an operator is a symbol in a language that performs an action or operation, right? And that can be against multiple values or just 2 values, 3 values, or just 1 value. We went over our arithmetic operators, which you're most likely familiar with, save the remainder operator, which is a little unique. We have our relational and comparison operators, which, again, you're probably pretty familiar with. And then we have our logical operators down here. So these, there's a good chance you're also familiar with these, so this all might be review. But there's also a good chance that, maybe some people have not heard of all of these operators. So it's honestly a good idea to get familiar with all of them and to know all of them, because they're all fairly useful and common when you're coding. So I hope this helps, and if this gives you a good foundation to move forward with. Thanks. So it's honestly a good idea to get familiar with all of them and to know all of them, because they're all fairly useful and common when you're coding. So I hope this helps, and if this gives you a good foundation to move forward with. Thanks.